All right, let's revisit the example of natural growth and decay. And remember that the equation for natural growth and decay is dy over dt is equal to k times y. All right, so when k is positive, it's a natural growth or exponential growth. So maybe I should write that. So when k is positive, then you would have a natural growth. And if k is negative, it's going to be a decay. All right, this is an example of a separable equation. So let's try to do that, solve this. All right, so since it's a separable equation, we can just simply divide through by y. So that way you would have 1 over y times dy over dt is equal to just k, right? Then we can take the antiderivative with respect to t. So integrate both sides of the equation with respect to t. Integrate with respect to t. Then we can cancel dt and dt here. All right. Then antiderivative of 1 over y with respect to y. Luckily, we know this one. Natural log of absolute value of y, which is equal to, right, antiderivative of constant k is kt plus some constant, say c. All right, then what we need to do is we can just raise e to both sides, right? So that way we can isolate, e to the natural log of y is going to e to the natural log cancel out. So you have absolute value of y, which is going to be equal to e to the kt plus some constant c, right? I'm going to rewrite it as this. This is, let's see, e to the kt, so I'm going to write e to the kt, right? Then times, you have e to the c. So I'm just splitting into two exponential functions this way. All right, then we need to get rid of this absolute value sign. So it's going to be either plus or minus. So y is going to be equal to, right, plus or minus e to the c, right? Then you have, let's see, e to the kt, right? It's usually, when you're talking about a population or something like that, it's going to be a positive one because we don't talk about negative population. So we can call this guy right here. All right, that's just a constant, right? Plus minus, e is constant, c is constant. So I'm going to just call it y0. So just a constant. So therefore, we have this equation. Y is going to be equal to some constant y times e to the kt. All right. All right. So let's look at an example of this natural decay. Carbon dating is a pretty example of that. Let's look at the number 35. All right. So somebody found a really old skull, and it contained the 1/6 of the original carbon-14 amount. All right. Then carbon-14 is going to have a natural decay. Then differential equation is derivative of the amount of carbon-14 divided with respect to time is equal to negative 0.00011216 times c. All right, so we know that this is going to amount of carbon-14 has a function. So c of t is simply some constant c0, which is usually the initial amount. E to the k is this negative 0.0001216 times time t. Right? Then human skull has 1/6 of the original carbon 14. So we're going to set that equal to 1/6 of C0, right? That way we know how old this skull is, right? So in this case, we can just divide both sides by C0 or cancel C0 out. Then we can take the natural log of both sides, right? If you take the natural log of exponential function, so e cancel out, so you're just going to get negative 0.0001216t is equal to, right, natural log of 1 over 6 is same thing as 6 to the negative 1 power, right? But if you have a power here, we can put it in front. So this is same thing as negative natural log of 6, right? So we can cancel the negative sign here and a negative sign there. So then we can just divide through by 0.0001216. So that way we can find t. So this is how old this skull is. So it's a natural log of 6 divided by this very small number, 0.0001216, right? And this came out to be, right, and punch it into a calculator, it came out to be about 14,735 years. All right, so this skull is 14,735 years old. All right, so this is called the carbon dating. All right, but amount of carbon is just a natural decay, so we can use this exponential function to describe that. All right, that's it. I hope that this was clear.